Good morning. So we start our last chapter of the year. We're going to take a look at what are called systems of linear equations in this chapter. A system of linear equations is simply two or more equations that intersect at some point. Another way of describing them is two or more equations that describe a particular situation, and we will get into that later. There is a heavy emphasis on word problems in this chapter, and that may have its own problems for some of you. But if you thought you were done with linear equations and rearranging equations, sorry. Okay, this chapter has to do with, again, linear equations. So we'll get started. And you can see we have a definition here. A system of linear equations is two or more linear equations involving common variables. So if one has an x and a y, the other does as well. Often referred to as a linear system. We talk about the solution to a system of equations as simply a shared point. And what that means is at some point, these two lines will cross. Okay? So we'll do an example. We're going to take a look at solving systems graphically, which simply means graphing them and seeing where they do intersect. And we're also going to take a look at using your graphing calculator to solve them, which is way easier. Okay? But again, involves rearranging equations. Okay? So, first we'll take a look at doing it simply by graphing them. So it says, graph the lines y equals negative 2x plus 1 and y equals 3x minus 4 using the slope and y-intercept. Which point belongs to both lines, and what do we call this point? So we'll graph them first. Okay? So for our first one, y equals negative 2x plus 1. Remember, when it's in this slope-intercept form, it is very simple to graph. Okay? I'm going to write the slope as a fraction. Our second line is y equals 3x minus 4. And again, I'll just write the slope as a fraction. Okay? So the first thing we can tell about these lines is one has a negative slope, so it's kind of going to be going like this. It's going to be going downhill as you go from left to right. This one has a positive slope, so it'll be going in the opposite direction. It'll be going uphill. So it shouldn't be too surprising that they cross at some point, right? Because one is going up, one is going down. Okay? So for this one, we know that our y-intercept is 1. For this, our y-intercept is negative 4. For our first equation, our slope is negative 2 over 1. For our second equation, our slope is 3 over 1. Okay? And just to review, that means our slope, thinking of it as a set of directions, means you're going to have to go negative 2 or 2 down. Remembering slope is change in rise over change in run. And you're going to go right 1. Right being the positive direction on our x-axis. Over here, they're both positive, so that means you're going to go up 3 and right 1. Okay? So let's graph them. We'll call this line 1 and this line 2. So for line 1, we have a y-intercept at 1, right here. And our slope tells us from any known point to get to another point, we simply have to go down 2. That's 1, 2, and right 1. That brings us to our second point. And then, using our ruler, we simply join them up. Okay? So, and we'll say this is our line 1. Okay? For line 2, we do the same thing. Our y-intercept this time is down here at -4. Our slope tells us to go up 3, 1, 2, 3, and right 1. Hey, same point. So now we have 2 points from line 2. We join them up. There's line 2. Now, which point belongs to both lines? That's the point of intersection. Okay? So, which point belongs to both lines? This point right here, which is, just let me clean this up a little bit, at 1 across and 1 down. So 1 and -1 is common. And the point that is common, the intersection point, is called the solution. Okay? So from here on in this chapter, whenever you're asked what's the solution, or you're asked to solve a system of equations, it's just a way of asking where do they intersect. Okay? So, intersection point is the solution. Whoops. Now, you don't have to use the x and y intercepts, but this is another way of doing it. Okay? So in the first example, we use the slope and the y-intercept. In this example, we're going to use x and y intercepts, which remember is simply another way of graphing our lines. So, we'll call this line 1, we'll call this line 2. So for line 1, 2x plus y equals 2. Line 2, x minus, ooh, that doesn't look good. There we go. X minus y equals 7. To find our x-intercept, remember we substitute a value of 0 for y because we know that all points along the x-axis, which is where the x-intercept is located, will have a y-coordinate of 0. So this becomes 2x plus 0 equals 2. The 0 just disappears. 2x equals 2. And then dividing through by 2 gives us a value for x of 1. So our x-intercept is at 1 and 0. Okay? Finding the x-intercept for line 2, same deal. We substitute a value of 0 for y and solve for x. This one's really easy. X minus 0 equals 7. The 0 disappears. X equals 7. So our x-intercept for equation 2 is at 7 and 0. Again, notice the y-coordinate is 0 in each case. Okay, let's find our y-intercept. Remember, for the y-intercept, it's intersecting with the y-axis, so it will have an x-coordinate of 0. So we sub in 0 where we see x, and this becomes 2 times 0 plus y equals 2. 2 times 0 is 0, so we end up with simply y equals 2, and our y-intercept this time is at 0 and 2. Finding the y-intercept for this guy, again, remember, we know that our x-coordinate will be 0. We don't have to be told that, we know that. So we sub in a value of 0 where we see x, and this one becomes 0 minus y equals 7. The 0 disappears and we're left with negative y equals 7. Well, we can't stop there. We got to have a positive y. So we multiply the whole thing through by -1. -1 times negative y is positive y. -1 times 7 is -7. That gives us our y-intercept. Okay, so let's graph these. For equation 1, we know that the x-intercept is at 1 and 0. That's right here. And we know that the y-intercept is at 0 and 2. That's right here. Remember, as soon as you have 2 points, all you got to do is join them up. There's our line 1. For line 2, same thing. Let's plot our intercepts. Our x-intercept is at 7 and 0, way out here. Our y-intercept is at 0 and -7, way down here. We've got our 2 points. Take Mr. Ruler, join them up. And there's our line 2. And look, there is our solution. Okay? Remember, the solution again is simply where they intersect. So in this case, the solution is at 3 across and 4 down. So our solution is at 3 across and 4 down. Okay? Now, if you want to know whether this is indeed the solution, and you didn't maybe make a mistake somewhere in here figuring out your x and y intercepts, you can verify the solution algebraically. Okay? Now, that sounds a lot scarier than it really is. What you need to do if you want to verify a solution algebraically is simply take the x and y coordinates at your point of intersection, that is your solution, and substitute them in where you see x and y. Okay? So, now we are verifying. So we're going to take our x value and sub it in for x in both cases. We're going to take our y value and sub it in for y in both cases. And then look what happens. So we'll do it for equation 1 first. This becomes 2 times 3, because we're saying our solution has an x value of 3, plus our y value, -4, equals 2. That gives us 2 times 3 is 6, plus -4 is -4, equals 2. And 6 minus 4 does equal 2. So we can say the left side equals the right side. Okay? If the left side equals the right side, then you're probably getting the right answer. But when you verify, you have to verify that both equations work. So we're going to have to do the same thing that we did here over here. So we sub in our value for x, which is 3, and our value for y, which is -4. And what do we get? 3 minus negative, which is the same as saying plus, 4 equals 7, 7 equals 7. So, again, left side equals right side. So, since our solution, 3 and -4, works in both of our equations, it results in the left side and the right side being equal, we can say, ka-ching, it is the correct solution. Okay, so again, verifying simply means going through this process, subbing in values, and seeing if the left side equals the right side. Okay? Next, using your graphing calculator. This is where it becomes oh so easy, because you don't have to get a grid and plot points and all that good stuff. all you need is to put your equations, so we'll say equations in slope y-intercept form. Okay, that's the only thing you have to do. So again, rearranging equations. Okay, so it says, solve the system of linear equations, x minus 3y equals 9, 2x plus y equals 4, using a graphing calculator. Verify the solution algebraically. So, step 1, put your equations in slope y-intercept form. Step number 2, enter into calculator. And we'll talk about that in a second. Okay? First, let's put them into slope-intercept form. And it looks like we've got enough room over here. So for our equation 1, yeah, you can see that. Okay, so equation 1 is x minus 3y equals 9. X minus 3y equals 9. We have to isolate y, so that means we're going to subtract x from both sides, giving us minus 3y equals negative x plus 9. And then we have to get rid of the negative 3. So we divide each term by negative 3, leaving us with y equals negative x divided by negative 3 will give us a positive result, 1/3 x. 9 divided by negative 3 will give us minus 3. So our first equation becomes y equals 1/3 x minus 3. Okay? So this guy rearranges to that guy. Equation 2 is 2x plus y equals 4. This one will be easier. The only thing we have to get rid of to isolate y is this 2x. So we simply subtract 2x from both sides, giving us y equals minus 2x plus 4, which we enter here. Okay, so our y2 is y equals minus 2x plus 4. Hopefully that made sense. Hopefully you're comfortable with rearranging equations by now. We did it for the whole of chapter 7. Now we're going to go to our graphing calculator. Okay, so here's our graphing calculator. We've got our equations, and what we need to do in order to enter them is, if you see in the very upper left-hand corner, there is the button that says y equals. And if we click on that button, first of all, you can see I've entered some equations here previously. I'm just going to clear them out. Put the cursor over the equation, press clear, and it disappears. Okay? I'm going to arrow down to get to the next one, and again press clear, and they disappear. Now I have enough room to enter these equations in. Okay, so my first equation, remember, was y equals 1/3 x minus 3, and my second one was y equals minus 2x plus 4. Okay? So I'm going to enter this equation. They've already put the y equals part in. Okay, so you don't have to enter that. You have to enter the right side of the equation, and if you have a fraction, you have to enter it in brackets. Okay, so we're going to put bracket 1/3, and then right in kind of the upper left-hand corner, there's a button that has X and looks like a T, an O, an N, that's your variable button, okay? So right up here where you can see the cursor, you're going to press your variable button, and look, it gives you a variable X, okay? So we've got the 1/3 X, now we just have to plug in the rest of it, minus 3. There we go, we've plugged in our first equation. If you arrow down with the cursor, that'll bring you to your next equation. And this one is negative 2x plus 4. Remember, when entering a negative, use the negative button, which is in the lower right-hand corner of your calculator. So negative 2, and then again we press that little variable button in the upper left-hand corner, negative 2x plus 4. Now the magic. Okay, we've entered this equation, we've entered that equation. Now what we need to do is we need to press graph, which is in the upper right-hand corner of your calculator. And as soon as we do that, ka-ching. Oh, just a second. There we go. If you press the zoom button, which is one of the 5 buttons that run right across the top of your keypad, and click on zoom standard number 6. Sorry. There we go. Zoom standard number 6 and press enter. Must be Monday. That will give you a more standard X and Y axis, okay? I would say that you should always start with the standard screen, okay? And just as a bit of explanation, each of these little hash marks, these little ticks, equals 1. So that means we can see that the x-intercept of one of our lines is at 2, and the y-intercept is at 4. Down here for our other line, the x-intercept is at negative 3, and the y-intercept looks to be at about 9. Okay? That's interesting. Okay. Intercept should be at negative 3, and the x-intercept is at 9. Good. Okay, but importantly, we have 2 lines, and you can see that they cross. Now, we can kind of eyeball this. We can see that the intersection point is here. So that's somewhere around 1, 2, 3 across, and 1, 2, and a little bit down. So somewhere around 3 and negative 2. But we don't want to know just kind of sort of where it is. We want to know exactly where it is. And so what we need to do for that is we need to do a little bit of fancy calculating, okay? Luckily, our calculator does it for us. So, you'll see right up here the 4th button over, the one that says trace, and then above it, it says calc. We want to access that calc function because we want to calculate the solution. So, in order to do that, we have to press the 2nd upper left-hand corner, the blue button, and then calc. And we want to find the intersection. So again, to access this screen, you press 2nd, trace, and that will bring you to the calculate screen. And then you want to go down to intersect, press enter, and it will bring you back, and it will ask you 3 questions. The first question is, are you on the first line or curve? And you can see the cursor is on the first line, so you just press enter. And then it will ask you the second question, which is, oh, am I on the second line now? Notice how it was here, now it's up here, and you say, press enter, to say, yes, you are on the second line. And then finally it will say, do you want me to guess? At which point you will click enter a third time to say, yes, I want you to guess. And what does it tell you? It tells you the intersection is at x value 3, y value -2, which you'll recall is what we had guessed. So our solution is at 3 and -2. Notice again the friendly blinking cursor. Okay? So to repeat, what we want to do is we want to, and I just press the y equals button, we want to enter our equations into the calculator. You don't have to put them in as 1 and 2. You can put them in as 2 and 3, doesn't matter. Okay? So our first equation, 1/3 x minus 3. Our second equation, -2x plus 4. Once they're entered, we press the graph button, which is in the upper right-hand corner, to give us our graph. To find the intersection, we press the blue second key and then trace, the one that's right beside graph. And you can either cursor down to 5, or you can just press the 5 key and it will automatically take you to the intersection screen, at which point, again, remember you press enter to tell it you're on the first line, enter again to tell it you're on the second line, enter a third time for it to guess. And there's your solution. Okay? We'll do one more of these. So let's go back to our lesson. There we go. Okay, we won't verify this because I've already shown you that and I think it's a pretty straightforward idea. Solve each of the following linear systems graphically using the method indicated. We'll do one of these because I really kind of want to focus more on the calculator stuff today, simply because I think that's what might give you a little bit more grief. Keep in mind, there are instructions for using your graphing calculator in the module. There are also instructions for using your graphing calculator in your textbook. Okay? Unfortunately, for those of you who don't have TI calculators, all the instructions are for TI calculators. Okay? You may have to go online if you've got a Sharp or a Casio or something like that, and see if you can find instructions for graphing linear equations. Okay, so for A, they're asking us to use the slope and y-intercept to graph these two lines. Okay? So again, remember you have to put them into y equals mx plus b, or slope-intercept form. The slope-intercept form for this one, remember we would just subtract x from both sides. That would give us y equals -x plus 7. Now remember, that negative is really a -1. And since we like to write these things as a fraction, I'm going to write it as -1/1. This one's not quite so easy to isolate, so we'll do it over here. 3x plus 4y equals 24. Remember, we want to get y all alone, so we're going to take 3x away from both sides, leaving us with 4y equals -3, -3x plus 24. Last step, divide everything through by 4. Remember, when you're multiplying and dividing, it's by every term. That leaves us with y equals -3/4 x plus 6, right? 24 divided by 4. Okay? So, for equation 1, our slope is -1/1, and our y-intercept is at 7. So let's graph our first one. Our y-intercept is at 7, that's right here. Our slope is -1/1, that means we have to go down 1 and right 1. bringing us to our second point. We can then join the points to give us our first line. Okay? For line 2, the slope is negative 3 over 4, and the y-intercept is at 6. Okay? So again, plot your y-intercept. It's at 6. And your slope tells you go down 3, right? Negative 3, and right 4. So we're going to do that. We're going to go 1, 2, 3 down, 1, 2, 3, 4 to the right. There's our second point right there. And using our ruler, we can join our points. And there's our line 2, all graphed. What's our solution? Well, remember, the solution is the place where the lines cross. So, in this case, our solution is right here. It's at 4 across and 3 up. There is our solution. Okay? Let's try graphing this one on our graphing calculator. Okay? So, go back to our graphing calculator. Erase. Well, actually, I'm not going to erase this. I just want you to see that it will look exactly the same. So, go back to your y equals button. Because remember, we've got these equations from our last question. We got to get rid of those. So, we're going to cursor down. We're going to press clear. And again, cursor down to the next one and press clear. We've cleared out our equations. Let's go back up and enter our equation 1, which remember is y equals negative 1x, or just negative x plus 7. So we'll enter that, remembering to use the negative key in the lower right-hand corner of your calculator. Negative variable key x plus 7. Okay? Our next equation was negative 3/4 x plus 6. So, bracket negative 3 over 4, close the bracket, press your variable key, x, and then plus 6. Okay, so negative 3/4 x plus 6. Now we have our equations entered, and remember, we press the graph button in the upper right-hand corner and watch the magic. And look at that. We basically get the same lines. Okay? Shouldn't be a surprise, we use the same equations. But I just wanted to leave this up here to show you that that worked. Okay? Some of your graphing calculators will do this same nice, have this same nice feature where they will colorize the lines. That way you can kind of tell them apart. Okay? If you go back to the y equals, you'll see that they are color-coded right here. Okay? So your blue line was your first equation, and your, I'm colorblind, not blue line is your second equation. Okay? So, we've graphed them. Now we have to find the solution. We know that it's right here somewhere. We already know that it's 4, 3, but let's go through the steps. So, you have to press the second button in the upper left-hand corner, and then the trace button, which is right beside the graph button at the top. And you want to pick option 5 to get the intersect function. So, it tells you, I'm on the first equation here. You say, okay, that's fine, press enter. And then it says, hey, I'm on the second equation now. Press enter one more time. And then it says, shall I guess? And if you press enter a third time, it will. And you can see it plops the cursor right at the point of intersection, and it tells you what the coordinates are. The x coordinate is 4, and the y coordinate 3. Okay? Good, good? We'll try one more, and then that'll be it for today. Okay? So, back to our lesson. Why don't we'll do F, okay? So for F, we want to find the point of intersection. Remember, your first step is you're going to have to isolate y in each equation. So for this one up here, 2x plus 5y equals negative 20. We subtract 2x from both sides, giving us 5y equals negative 2x minus 20. And then we divide through by 5 to give us, here's our first equation, y equals negative 2 over 5x minus 20 divided by 5 is 4. Okay? For our second equation, which is 5x minus 3y equals negative 15, we subtract 5x from both sides. That gives us a negative 3y equals a negative 5x minus 15. And then to isolate y, we need to divide every term by negative 3, leaving us with y equals negative 5 divided by negative 3 will give us a positive fraction, 5/3 x. Negative 15 divided by negative 3 will give us a positive y-intercept, plus 5. Once your equations are in y equals mx plus b form, you can then go to your graphing calculator and enter them. So we'll do that. Here's our graphing calculator. Again, remember, the first thing you do is press the y equals button. You have old equations to get rid of, so you clear, cursor down, and press clear, and enter your equations. Okay? Your first one, y equals. Your first one is y equals negative 2/5 x minus 4. So again, they've already done the y equals. You just have to put in bracket negative 2 over 5, close the bracket, minus 4. Notice the negative sign is slightly smaller and a little bit raised compared to the minus. That will become important if you make a mistake and use the minus sign instead of the negative sign. It's fairly easy to see the difference when you go back to check your equations. Okay? Enter your second equation, which is bracket 5 over 3, close bracket, plus 5. Once we've entered both equations, we press the graph button in the upper right-hand corner. And there's a line. And there's a line. And it doesn't look like they intersect. They do. Okay? Now these lines look almost parallel, but we know that this one has a positive slope, so it's ever slightly going up. This one has a negative slope, so it's going ever slightly down. So if we could continue this graph along the x-axis until I leave the screen way over here to the right-hand side somewhere, still here, way over to the right-hand side, they would eventually cross. So, what do we have to do? We have to extend the x-axis. How do we do that? That's where this key right up here called the window key comes in. If you press the window key, it will say, how would you like to change the way that your graph appears? And what we said was, we want to extend our x-axis. So right now it's telling you the biggest number that they'll show is 10 on the x-axis. Well, let's change that. Let's cursor down to where it says x max, and let's change that from 10 to 100. And then press graph again and see how that changes things. Okay, there's our first equation, there's our second equation. Now, they're going, remember this is x equals 0, this is x equals 100, not 10 anymore. We still haven't gone far enough. So what we're going to have to do is we're going to have to go back to our window, and this is just a guess and test thing, okay? We're going to go back to our window, and we're going to set our x max now for 1,000 and see if that helps. Okay, so instead of 100, it's, whoa, my mistake. Just let me back up and delete. Now it's at 1,000. Now press graph and see what happens. Oh my goodness, they're going on forever. Okay, so we're going to go back to our window and we're going to make our x max really big. We're going to make it 10,000. And we're going to press graph again. Oh, good Lord. So it's at this point where you might want to ask yourself, have I made a mistake here? Okay. Now, I don't know. I may have made a mistake in rearranging the equations. I'm going to go back and check. Okay. So back to our original problem. So this should be negative 2 over 5x and minus 4. So this one looks okay. How about this one? This one should be minus 5/3 x. And that is definitely, yes, that one is also correct. So that simply means we're going to have to go back and we're going to have to fight with it some more. So back to our graphing calculator, and why don't we let's make our window really big and let's go down and let's make it 100,000. And press graph again. Well, it looks as though these lines are not cooperating. I'm going to guess and test one more time, and then we're going to say this isn't worth doing. So I'm going to make my x minimum very big. I'm going to make it negative 100, 3,000, and I'm going to make my x max 1, 2, 3, 1, 2, 3, 1 million. Oh, good Lord. Okay. Now, this is a really good lesson. because I messed up. And I just noticed, let's go back to our original equations. The mistake that I made, I forgot to enter in the variables. Okay, so I'm going to just clean this up. This is embarrassing for me, but it is a good lesson. So, our equation is -2/5 x minus 4. I forgot to put that variable in, so minus 4. Some of you may have noticed that a long time ago, and you're probably laughing a whole bunch right now. And x plus 5. Now I'm going to put my window back to normal by pressing zoom, and I want the standard window, so I want 6. And now you'll notice that when they're graphed, they look very different because they have variables. And we can very quickly go back, and again we're going to press second, we're going to press trace. That will bring us to option 5, the one we want, which will bring us to our intersection. And then it's simply a matter of pressing enter 3 times. Once for the first curve, once for the second curve, and once to guess. And don't worry about the decimals. Just round to the nearest tenth. So our x value is -4.4. Our y value is -2.3. And after a lot of legwork, we did finally arrive at a solution. Okay? It's really important that you practice a few of these. Speaking of which, I will be doing the practice questions for your assignment booklet in a later video. Have a great day. Sorry it took so long. Bye.